Hey guys, Buildzoid here, and this is hopefully going to be a quick follow-up video to the previous video about 13th gen, 14th gen CPUs not being stable, like some 13, I should specify some, okay? It's not all, but some 13th gen and 14th gen CPUs aren't stable on like out-of-box settings on a lot of motherboards. It's not even necessarily just high-end ones, but yeah. Anyway, today we're going to address a topic that I didn't address in the video because I'm not sure that my understanding of this part of Intel CPUs is actually correct, because it doesn't really make any sense to me. Though, yeah, so I'm just not sure about it. But anyway, it was brought up by this comment on r/hardware, so credit for, like this person's directly responsible for this video existing now. But yeah, the original video got posted to r/hardware, and then there's this comment over here. All CPUs degrade over time. That's why their fused VF curve have a sizable buffer to account for derating. This is completely true. This is why you can undervolt things. If everything shipped with already at minimum voltage, then you would you'd find a lot of things that after a few years, they don't work anymore. So undervolting is basically taking the reliability buffer and removing it. But anyway, that's not really the part of the comment that I wanted to focus on. It's this part. Asus Gigabyte, and from what I observed to a lesser extent, MSI ASRock Z boards set an AC load line, AC_LL, and LLC level that undershoots the voltage frequency curve significantly under load and eat into this buffer. Because AC/LL undervolts increase in size as CPU amps increase, unlimited power results in more undervolting relative to the voltage frequency curve. My guess is that a bunch of these people who are reporting newly unstable CPUs never had stable default configurations at max power, or were borderline stable, and aging environment pushed them over the edge. And then we also have like a word on clock stretching. And funnily enough, Alder Lake and Raptor Lake CPUs also have a clock stretching feature called IASEP, so that's Intel Architecture Current Excursion Protection, to account for the Vcore undershoots, but due to the aforementioned AC load line undervolts causing it to trigger constantly under load, it's disabled by default on Z-series boards that this person has tried. And yeah, as far as I know, this is true. And the reason it's disabled by default is because if this is turned on, you lose a lot of performance if the CPU is running at less voltage than it's supposed to, or like less voltage than the CPU thinks it needs. So yeah, you lose a lot of performance if this is turned on and the CPU thinks it's like not getting enough voltage. So it's turned off because yeah, like Intel doesn't require it to be turned on. In fact, there was like a bunch of news articles recently about how even more motherboards now disable this by default, even on non-K CPUs. So that's great. But anyway, back to the AC load line topic, because this is the part that I don't get, and honestly, it's definitely worth addressing. So again, I don't actually get what's going. It doesn't make sense to me how Intel's like AC/DC load line specs are supposed to work. Maybe that's why these CPUs crash, because they don't actually work, and I'm not stupid. Like what Intel has done doesn't actually work, and I'm understanding it perfectly, and that, but maybe I don't understand it anyway. So here we have DC load line for S processors, and this is the 13th gen processor electrical specifications, right? So we have DC load line for S processors, so that's socketed processors, 65 watts, 125 watts. And the spec is 1.1 milliohms. Or, well, the maximum is 1.1 milliohms, and the minimum is 0 milliohms. And this is the part that doesn't make sense to me, because, like, this, at like 200 amps, this is going to be a 220 millivolt V-droop. There's going to be 220 millivolts of V-droop if you have a load line of 1.1 milliohms at 200 amps. And with a load line of 0 milliohms, there's going to be 0 V-droop. So that already just, like, I don't, like, how do you, like, if at the factory you test a CPU that, hey, it's stable at 200 amps and 1.2 volts, and then you ship this CPU out into the, and you test it like 200 amps, 1.2 volts, 1.1 milliohm load line, and it's perfectly stable, right? And then you ship this out into the wild, and then the motherboard, or I don't know, maybe you test it like 0.5 and it's stable, and then you ship it out and a motherboard runs it at like 1.1 million ohms of load line, and the voltage ends up like significantly lower or higher. Like, this is the part that I don't get, because it actually seems to be working kind of backwards. As we'll get to, there's like a bunch of notes about how the load line works that make me very confused, because like Intel's DC AC load line settings, like compared to how, say, NVIDIA voltage rate, like NVIDIA has a voltage regulator spec, that makes perfect sense to me. Intel's like how load line is implemented on that makes sense to me. How Intel implements it doesn't really make a lot of sense to me. But anyway, but the AC, like that comment was mainly about the AC load line setting. So let's take a look at what Intel recommends for the AC load line setting for S processors, right? And for S processors, they recommend same as DC load line. Right, so basically AC load line is supposed to be set to anything from 0 milliohms to 1.1 milliohms, which is that's a spec apparently. Like that's yeah, apparently, any load line between 0 milliohms and 1.1 milliohms, totally cool. That's a spec. Anyway, so let's read some of the notes relevant to the AC load line here, which is like 10, 13, and 14. So 10, load line measured at the sense points. Basically, Intel gives the CPUs from Intel have like dedicated voltage measurement points, so you're supposed to measure your load line from the sense points. And then 13, load line spec values should not be exceeded. Okay, so you're not allowed to set your load line higher than what Intel specifies over here. That's cool, I guess. If exceeded, power, performance, and reliability penalty are expected. Now, I don't get how there's supposed to be a power penalty, because if you increase the load line, that should lead to more VDroop, which should lead to less power consumption, not more. So that's why I'm like confused about how Intel's load line is implemented, because it seems to work backwards. Like, if you set the load line really high, the CPU like requests a really high vid to sort of compensate for the really high load line. And that seems to even make, like, and then when you read 14 over here, load line should be measured by the VRTT. So this is like a test tool for the voltage regulator that's provided by Intel to the motherboard manufacturers. Should be measured by the VRTT tool and programmed accordingly via the BIOS load line override setup options. AC/DC load line BIOS programming directly affects the operating voltage. So that's the AC load line directly affects the operating voltages, and power measurements. That's so the DC load line basically affects the power measurements from the CPU. And so basically, yeah, if you mess with the AC load line, you get different operating voltages, and if you mess with the DC load line, you get different power readings. A superior board design with a shallower AC load line, so less. So like 0 milliohms is, I would assume 0 milliohms is the most shallow, and 1.1 milliohms is the most deep. Yeah. Anyway, the deepest load line. AC load line, so with a superior board design with a shallower AC load line can improve on power, performance, and thermals compared to a board design for POR impedance. I don't know what POR stands for. I've heard of POL, which is point of load, but POR, point of resistance? I'm not entirely certain what that's supposed to mean. But anyway, so reading this, a superior board design with a shallower AC load line can improve on power, so I'm going to assume reduces power consumption, increases performance, and reduces thermals. So this sounds like if you set the AC load line really, really low, the CPU runs on less voltage. And apparently we're going to trust the motherboard vendors to measure what the optimal AC load line is themselves using a test tool, not real CPUs, and then we're just going to pray that it actually works in practice, I guess. Like, this statement to me is like this is basically asking for things to not work if you're Intel. It's like, yes, we will tell the motherboard manufacturers that they can mess with the operating voltage of the CPU. And it's like, oh, but they're supposed to do it according to these guidelines of the like this voltage regulator test tool. But like, how accurate is that test tool to real world CPUs? Right? How similar is it to real world CPUs? Like, a lot of people I've heard from are like, apparently Unreal Engine is like especially bad for the instability, right? So maybe this workload here is exceptionally like noisy on the power delivery, which wouldn't surprise me. Like anything that's like kind of memory intensive and also hits all of the cores, has a tendency to cause. I mean, Cinebench isn't really memory intensive, but if you screw up your load line settings enough, even Cinebench is going to crash. So like, like maybe this is significantly noisier than the worst case transient loading that the VRTT manages to produce. In which case this tool is like not good enough. Or maybe the motherboard vendors use this tool and then just like don't use it properly. And like, quite frankly, I don't know why you'd let the motherboard vendors mess with this. Like, this just doesn't like, this is like asking for things to go wrong. Right? Is like, no, you should decide that there is a, like, the CPU runs at this voltage for this frequency, and you don't get to mess with it unless you're actually like manually overclocking it. Like, out of the box, the CPU should behave as it did when Intel like freaking validated it. Right? Unless Intel wants to go and like, because this is the thing, is like, evidently there's like a mismatch between how Intel validates their CPUs at the factory and what the motherboard vendors think they're going to work at. Right? And this right here is like, yeah, so the motherboard vendors can set like whatever AC/DC load lines according to this tool that Intel is provides them with. But if the motherboard vendors aren't using this tool correctly, then this is a stupid idea. And Intel would have to basically go and like validate each CPU on every single motherboard to account for the fact that like every motherboard might run slightly different voltage, because Intel's like, yeah, you can just change the load line settings based on the voltage regulator of your motherboard. So each motherboard with a different voltage regulator is going to run slightly different voltages. And then you need to prove that the CPU is going to be stable at those slightly different voltages across all of these different motherboards. This seems like a really good way to try design something to be reliable. Like, so if I'm understanding how this works correctly, which is that, so basically we have a bunch of high-end motherboards that seem to be setting the AC load line really, really low. Then they blow out the power limit because Intel doesn't actually care about the power limits, right? That's why they're a recommendation and not a spec. And similarly, we don't even have a spec for the load line, right? It's just like, yeah, you can run... we trust you to set the load line correctly using this tool that we're providing. And it's like, what? Why would you ever do this? Like, because the other issue that I see is like, the motherboard vendors don't, like, they're not able to test as many CPUs as Intel is, right? Intel makes the CPUs, the motherboard vendor, so Intel needs to tell the motherboard vendors what load line is necessary for the CPU to function, right? So, like, if Intel if Intel validates the CPU at the factory with drastically different load line settings than what most real-world high-end motherboards run at, then chances are that CPU isn't going to be stable, right? Because it was tested differently at the factory than it ends up running in the real world. And reading this, it seems to me like they were just asking for this to happen. Because this is ridiculous. Like I don't know how else to read this. I mean, yeah, you could throw some of the blame on the motherboard manufacturers for like apparently not figuring out how to use this test tool correctly. But for all we know, this test tool is only accurate to the behavior of the top 50% of Intel CPUs manufactured, and everything below that top 50% isn't going to behave the way the test tool does. Or maybe it's bottom 10%. I don't know. But like, there is a lot of chips that like aren't running correctly, to the point that like NVIDIA is telling people to go complain to Intel about this. And, so like evidently there's like a major mismatch between how Intel validates a CPU as functional and what the motherboards actually do with that. Because and like partially Intel doesn't spec a power limit. Intel doesn't really spec a load line as far as I can tell, because like, you can just punch in whatever you feel like. As like we're assuming that you use the tool correctly. That's assuming the tool doesn't put out garbage results. And then, of course, we have the situation where you have just CPUs that don't work under a high load. And it's like, yeah, this is why you should maybe specify a load line instead of, like, letting board vendors mess with it. Because that's just, like, as far as I'm concerned, that's just asking for them to do it wrong, right? Especially when it's like, a superior board design with a shallower AC load line can improve on power performance and thermals. Nowhere does it mention reliability, I should point out. And of course, if you're a motherboard vendor and you read this, it's like, okay, well, superior board design, that's difficult to do. But you know what isn't difficult to do? Massaging the AC load line numbers. So if you just intentionally set these wrong, as in too low, or slightly too low, or maybe really too low, right? Like, who knows? And it's like, oh yeah, our motherboard is gonna, in reviews, our motherboard is gonna pull less power, it's gonna deliver more performance, and the thermals are gonna be better than motherboards that set the load line correctly. And this is why you should have a bloody load line spec. And not leave it up to freaking motherboard vendors to decide what the hell they want to run. Because, like, they're just, like, there's no, like, there's no, like, this is, like, you say, oh, yeah, if you lower this, regardless of, because that's the logical conclusion. Yeah, it's like, okay, well, what if we just lowered it anyway? Oh, the board doesn't actually meet the AC load line requirements that we're running? Well, it works on most CPUs, so that's fine. Right? So, yeah, no, as far as I'm concerned, this entire situation is entirely on Intel, because if you write a data sheet that's like, yeah, you can just mess with this, then they're going to mess with it. And if you don't create some extremely robust, like, testing requirements, and then, like, rules for people to follow, they're not going to follow your damn rules. Like, this just, what? Why would you let the motherboard vendors do this? Do you see NVIDIA letting the motherboard vendors test their own load line settings? No, because NVIDIA knows that if they let the freaking GPU manufacturers mess with the out-of-box voltage regulator configuration, there's going to be problems. Like, I'm not a fan of a lot of the, like, overclocking and restrictions that NVIDIA puts on their GPUs, but, you know, as far as providing a functional out-of-box experience, they're better at it than Intel. Because they just, like, here are voltage regulators you are allowed to use. These are the settings you are allowed to run them at. If you don't run them at that, we stop sending you GPUs. Also, you can't put too many power connectors on our GPUs either. Actually, you can't really do anything with NVIDIA cards without NVIDIA's permission. And then there's Intel, where it's like, yeah, we're just gonna, you know, just set the load line. It's gonna be fine. Like, there is absolutely no, you know, reason to not set this correctly. Should have probably mentioned that, hey, if you set your, you know, AC load line too low, it's going to drastically impact reliability. But they of course didn't bother to mention that because, I don't know, they think they're too good for that or something. Because, yeah. Like, maybe I'm completely wrong about how I'm reading this, but to me this really reads like Intel was just asking for this to happen. Because it's like, you do not let the board vendors mess with the operating voltages. That is dumb. Especially on auto settings. Like, it's fine. Like, I wouldn't have a problem if, like, Asus had, like, a Asus enhanced profile and then, like, it voids your warranty and blows up your CPU. But the problem is that these motherboards don't work after a clear CMOS. Right? Like, you cleared the CMOS and you would think you would get the, like, Intel validated settings, but the thing is, Intel doesn't validate anything. The motherboard vendors validate the load line settings, because Intel apparently can't be bothered to just decide, hey, this is the load line you're going to run. This is the voltage, this is the power limit you're going to run. This is the current limit you're going to run. And then if you want to go outside of that, then you can have a toggle for going outside of that. But you can't just default to, hey, run whatever load line with whatever current limit, with whatever power limit you feel like. And if it doesn't work, well, too bad. And the other thing that sort of annoys me with this whole situation, and like Intel's response to this about like, hey, we're conducting an analysis. These guys are really, really quick to like disable any BCLK overclocking exploits, right? Like 6th gen Intel CPUs had a BCLK overclocking exploit. 12th gen non-K CPUs had a BCLK overclocking exploit. Those get patched. Intel is really quick to put out a microcode update that disables those BCLK overclocking capabilities on non-K CPUs. But making sure that the high-end CPUs, like, I don't know, actually work under all core loads, investigating that. Really, really just amazing.